Okay, so now let's look at how to compute the probabilities for y equal to 0, y equal to 1 and y equal to 2 for any given record. So a new case, for example, okay, let's say that the parent either one of the two parents as college is a graduate, so let's say that's not so. Is this the public university? Not so. And GPA say 3.26. Okay. So this is the predictor profile. Okay, so what is the probability of y equal to 0, 1 or 2? Now the first model will give us the probability that y is equal to 0, because that model, the target is apply 0 is 1, otherwise it is 0. So if you set up your L here from the first model, so which is that, right, plus some product of the coefficients with the predictor values. So that will give us the value of L, okay, for that profile. Okay, and then we can do EXP of minus L, and then 1 over 1 plus e to the power of minus L. It will give you the probability. Okay? Any questions so far? So now you do the same thing for here. So that will give us the probability for apply 0, 1. So that will be the probability that apply is less than or equal to 1, which means probability of 0 or 1, right? Because it is ordinal. Okay, that now the target for model 2 represents values less than or equal to 1. Okay, so if you do this for the second model, b sub 0 plus some product of the b coefficients, comma, the predictor profile. Okay. So that will give us our new L, right? Now copy that down here. Okay. So now we have everything we need to find the probabilities of y equal to 0 is just that, because that's what model 1 is. Okay. Now probability y equal to 1 will be that minus that, because the second one is the probability of y less than or equal to 1, so that covers both 0 and 1. So we take away the probability of 0, so what we are left with is probability of y equal to 1. And this works because it is ordinal, otherwise it will not work. Okay. So now these are the only 3 possibilities, so the remaining probability must be equal to something that will give us the total of 1, or we can even do this. So it should be 1 minus that. So because 2 is the opposite of less than or equal to 1. So 1 minus that will give you. So now we can check this out, make sure that these 3 probabilities must sum to 1, and that will be the case. So if you have more than 3 probabilities, right? I mean more than 3 values for the ordinal target. So instead of 0, 1, 2, you have 0, 1, 2, 3, 4, 5. Okay. Same process will work. So you have to define the first model, okay, for the first value, second model for the second value less than or equal to the second value. Because it is ordinal, that will work. So less than or equal to second value will cover second value and the first value. And then another model, keep going, okay, so you need one less than the number of possible values, one less model than the number of possible values. Okay. And then each of the model will give you cumulative probability, so you have to find the difference for the individual values. Okay. So any number of classes, any number of values for the class target will work in this process. Okay. So it would rarely be the case where there would be more than 3 or 4. Usually, most of the time, you'll have a binary target. That's what you'll be interested in. So sometimes you may have a non-binary target. That's not usual. Okay. Any questions on ordinal?